Sorry, I muted myself too, like an idiot. Oh, I'm recording this also. Haha. So the goal of this problem was to find the slope of this line. Now, if I write a regular line equation, is y equals mx plus b. So I wrote that, except I have the b value and the line we said specifically right here. Where'd it go? The line goes through like the origin. Oh, maybe it's on top at the beginning of the line. Wait, passes through. Oh, here. The word origin is right here. So we know that's 0, 0. So my b value has to be 0. That's why I put 0 here. And then I solve for slope. Now they wanted to find the change in slope because they wanted this to be either super steep or super shallow. And they wanted us to figure out, well, the line with the minimum slope or maximum, there's no maximum, but minimum slope would be when the line would be something like this, would be not as sharp. This would be a large slope, and this would be a small slope. So we just took the derivative. Instead of taking the derivative of y, I went ahead and plugged in y right here. When we did the quotient rule, we ended up with x squared. And you're right, it disappears. I stopped using it here. And the reason why is we're looking for critical points, and critical points in their fraction is when the top goes to 0. Like 0 over 5 is 0. 0 over 10 is 0. I don't give a crap what's on the bottom. So we just made the top go to 0. It turns out that was factorable. And we have plus 3, minus 3. And if you look at minus 3 is nowhere in the graph. So our only value is a positive 3. And if you look at the video, I plugged in a number on the left side of 3 and the right side of 3. And the slope of the slope goes from a negative to a positive. Negative to positive, so that would mean it's a minimum. That's why I said C. Hey, that's a really good question. Whenever you're solving for 0, it's always a numerator. The top goes to 0, because 0 divided by anything is still 0. Okay, good. Okay, that's really intuitive. So these questions, the styles repeat. Okay, which of the following describes the x-coordinate of the points on a curve of cosine x equals to e to the y in the xy plane, where the curve has a horizontal tangent? The hint in this problem is already when they said horizontal tangent. So horizontal tangent is when the slope is, hey Christina, horizontal tangent, right? The graph does this, that's my horizontal tangent, and that's when y prime is equal to 0. That's our slope. Why do we refer to it as y prime? When you talk about slope, that's rise over run. So that's always y over x's. That's the idea, right? It's y's over x's. That's a rise over run. That's why we always write dy over dx. So if you look back here, how could I get dy over dx? Because we're figuring out whatever this graph is, and I really don't know what this graph is. Like, I really have no clue. But I know that if I can figure out where this derivative, where dy over dx is equal to 0, we know that's a horizontal tangent line. Okay, so there are a lot of key words here. And I can't stress that. I take this all the way back to like first semester, week 1 stuff. But here, horizontal tangent, I'm thinking that the slope is 0. How do I get slope? That's the derivative. So we have to take the derivative of something. Well, I know in this case, I have y and x's. That's probably going to be dy dx because that's slope, rise over run. So I'm always running with these, like looking for the basic way of explaining these problems. Let's go take the derivative here. Cosine of x, the derivative of cosine of x is negative sine of x, and then derivative of x, we'll call it 1, is equal to derivative of y is e to the y, and then chain rule, derivative of y, we're saying y prime, or dy over dx. And we're going to solve for this guy. So negative sine of x over e to the y is equal to dy over dx. Now, we want the slope to equal to 0. So do I care about what number is on the bottom? I don't. So that's one of the cool things is that I don't care about y. So when is negative sine of x equal to 0? And then, so if you want, you can draw, I mean, you might know this already, but I'll just draw it out real quick. This is a regular sine graph. A negative sine graph would go the other way, but it doesn't matter, right? So that's going to be at 0, pi, and 2 pi. And we look at the answer. A says n pi, if you remember in pre-calc, n pi means some number times pi. So whether that's 0 pi, 1 pi, 2 pi, and this would work because this continues. Half pi means we would have been right here, every half pi. Sorry, in this case, it was a half pi plus n pi. So half pi then here and here, which is not our case here. This one here is 2 pi n plus pi. So they want to start off at pi and go 2 pi, which is not our thing. And what else? The value of 2 and pi, this is just every 2 pi. So our answer was only A. Okay. Any questions about this one? I thought we can talk. He just can't hear us. No, when I mic everyone, you guys can talk. You know what? If I stop the video for a moment, let me stop it. Okay. I have to unmute myself. So I got all excited. I'm talking to myself. I'm super excited. And I realized I have myself on mute. I can't see. Let's go back. Okay, so let's pretend to be really excited about this again. All right, how many points on the curve? Some crappy equation on the xy curve. So I mentioned when I was on mute that I have no clue what that looks like. That is like crazy. That's not a circle. Even if it was, I don't know. All I know is that they're going to ask me a easy part of this, which is here. Does a curve have a horizontal tangent line? And we just did that. Horizontal tangent is when y prime or dy dx is equal to 0. We want the slope to be 0 no matter what that graph is. So we're looking for dy dx. Is there a way for me to get dy dx from here? I hope so. It's just the derivative. So we just take the derivative straight. So the derivative of x 2 over 3 would be 2 over 3 x to the negative 1/3. And then 1/3. And you can write dx if you wanted to, but normally I'm just going to say that's 1. Dx over dx is 1. Now, to show all the work, what I learned later in college, I didn't learn this in my AP class because my teacher sucked. Maybe somebody else can relate, is that when I'm taking the derivative, this is what I'm actually doing. I'm taking the derivative of this with respect to this. So we take the derivative to, right? That's actually what we're doing. And the derivative of 9, that's a constant, so we know that's going to be 0. But this is a lot to write. I feel like sometimes it's a lot to write. And since this is a plus, we can do them separately. But the derivative of this guy would be power rule, x negative 1/2, and then, 1/3. And then derivative of x over x, see, that's why this becomes a 1. So we're going to write that as 1. And then plus the derivative of y, Same rule, do over 3 power rule first, -1/3, and then we're going to write dy over dx. And dy over dx here doesn't divide out. See, the derivative of y is dy over dx. So we're just solving for this guy now. So let's start getting rid of stuff. 2/3, I'll write y on the bottom, is equal to 2 over, that's a 1/3, okay? 2/3 x to the 1/3 on the bottom. That's going to be a negative for us because we moved it over. I'm going to cross multiply. Oh, dx is on dy over dx. I'm going to go and multiply this over to the other side. So dy over dx is equal to 2/3. I'm going to write the cube root of x. Sorry, because that's a little 3 there. Cube root of x. And then on top, we're going to multiply this by the reciprocal of 3/2. And we're going to stick the cube root of y on that side. So dy over dx is equal to the 2's and the 3's divide out, and we're left with the cube root of y over the cube root of x. We said specifically that when we're solving for 0, we just want the top to become 0. So when does 0? That's when y cubed y is equal to 0. Y is equal to 0 cubed, which is y is equal to 0. I don't know what the answer is. So how many curves does the line have? So we know when y is 0, this gives me a horizontal tangent. Now, if I go ahead and plug this back into the problem, x 2/3 plus y 2/3 equals to 9. And we said y was 0, x 2/3 equals to 9. So x is equal to 9 to the 3/2. And in this case, I did a square root, so we need to plus and minus. So I'm looking at there's 2 possibilities here. Just real quick, the square root of 9 is 3. 3 squared is 27. So I'm saying plus and minus 27. So real quick, I'm going to really quick. No, actually, no, I can't save this. Let's see. Can I hop over? Yeah, let's try this. Uh-oh. They're going to know my Zoom account stuff. Okay. Desmos real quick. Just real quick, just to show you this. X to the exponent. Where's my exponent? Function. Oh, there it is. I'm sorry. Darn it. 2/3 plus y power parentheses 2/3 equals 9. Come on. What the crap is this graph? And we said the answer was, what is this point over here? Is that like 27? Okay, so that's when the horizontal. So yeah, there is 27. See that? That's when we have a horizontal tangent. At positive 27 and also at negative 27. Okay. We pause. Okay, problem number 10, our last one. Oh crap, given another crappy curve, like how the hell am I supposed to do these problems? Like when I first see these prompt, I feel that the way that you guys do. I think, oh my gosh, what is this? Like Mr. Code never taught this. Like, I've never seen that in my life. What's that? Y to the second power? It should look like this, right? It's like like a gnome on a dwarf, like on an orc or something. Like they're riding each other. Like what in the world? Okay. But I need to get to read the main question. For what values of y, if any, does the derivative of y with respect to x not exist? Oh, okay. The derivative of y with respect to x does not exist. All right, we can figure that. Whenever something doesn't exist, that's it. Maybe it by a square root. And if it's a square root, okay, or this can be like 0 on the bottom. Okay. Sorry, I just got stuck because I'm listening to the principal talk about using Zoom and how we can't record. Okay, all right. So y 2 to the y equals to x. Oh, no, that's not how it's written. Oh, lucky me. That's not it. I can see it now. This is y 2 to the y power. These are multiplying each other, which makes my life a little easier. Okay, so we take the derivative. So product rule, dy over dx times 2 to the y plus the derivative of 2 to the y is 2 to the y ln of y, and leave y alone. How do you feel about that? Good? Give me a second, I'm tapping a note for myself. No school Friday. So no school Friday, guys. Okay. All right. Then we're equals to 1. Is everyone okay why the derivative of x is 1? Dx over dx is 1. So you have the right one. It's not 0. It's 1. The derivative of a constant 0. That's not it. Okay. Mr. Code, that's not it. Did I make a mistake? Derivative of y, dy dx. Leave the back alone. And derivative of the back. Oh, shoot, you're right. Thank you. Thanks for catching that, Andrew. It's ln of 2. Okay. And then you're right. Sorry, they're talking. It's hard for me to do this and listening to the principal at the same time. Wait, what am I doing? That is right. Yes. And then y equals to 1. Thank you. Great. Thank you, Charlie. And I think I wrote that now. Okay. Thank you. All right. So our goal is to solve for dy over dx. Now, next. So dy over dx, 2 to the y plus 2 to the y equals to 1. Just to make sure we got this guy. We got this guy. Oh, we forgot ln of 2. I'm glad I checked. Ln of 2. And then y. Yes, dy over dx is a chain rule because the derivative of y. Let me do that a little bit over here so you guys can see it. D over dx of 2 to the y is 2 to the y ln of 2, and then derivative of y is dy over dx. Okay. We divide that over. Dy over dx is equal to 1 over, is okay, I'm going to factor out, save time, the 2 to the y, 2 to the y, oops, 1 plus natural log 2, I'm just going to go y there. Now, we're trying to make this go to 0 on the bottom. So I'm going to go ahead and make that go to 0 right here. 1 plus natural log 2 of y is equal to 0. Now, let me ask you this question here. Does this ever become 0? 2 to the y? Looks like that. Never 0, so don't worry about it. Thank you for your head nods. Wait, why is it 1 over? It's because I divided this whole section here to the denominator. Divided all of that over to the denominator. Thank you, Maddie. And then we're going to go ahead and finish this by solving for y. When will this ever become 0? Natural log 2 y is equal to negative 1. Y is equal to negative 1 over ln of 2. That's the only time this will ever be 0 on the denominator. This is the only time we end up dividing by 0. And turns out that's our answer here. So let me ask you, what was hard about this problem? Was the derivative hard to figure out in the end? Was it really that hard to figure out? You could practice this a couple of times, right? It's something that we've been working on. Was us factoring it out hard? Was that part hard? Was solving for y hard over here? So most of that stuff is all algebra too. It never goes to 0. No. 2 to the y. Yeah, thank you. 2 to the y never goes to 0, but this part goes to 0 in the back. Cool. Okay, I'm going to stop this.